Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll take a practical look at Amazon EventBridge, a powerful, fully managed event bus service designed for building event-driven applications at scale. We'll walk through what EventBridge is, how it fits into modern AWS architectures, and explore real-world use cases for integrating microservices, SaaS applications, and AWS services through events. Let's get started. Amazon EventBridge is a fully managed serverless event bus that makes it easier to build scalable, event-driven applications by facilitating the flow of events between services, applications, and systems, without the need for custom polling or tightly coupled integrations. At its core, EventBridge acts as a central nervous system for your cloud environment, enabling services to emit events and others to respond to them asynchronously. Whether the source is an AWS service, a SaaS application, or a custom application emitting domain events, EventBridge can ingest, route, and deliver these events in near real time. One of its standout features is schema discovery and registry. EventBridge can automatically detect the structure of your events, catalog them, and generate code bindings to help your applications consume events consistently and accurately. Routing is performed through powerful rule-based filtering. You can match against specific fields in the event payload to direct events to different targets, such as AWS Lambda functions, step functions, SQS queues, SNS topics, Kinesis streams, and more, allowing you to build complex workflows or trigger real-time analytics pipelines effortlessly. Reliability is built in. EventBridge handles retries automatically, and you can configure dead letter queues to capture failed deliveries for further inspection and recovery. It also supports cross-account and cross-region event delivery, making it ideal for multi-account strategies or global applications that need to operate across AWS partitions. To truly appreciate the power of Amazon EventBridge, it's helpful to understand its evolution from Amazon CloudWatch events. While both services share the same foundational engine, EventBridge represents a significant leap forward in how we design and implement event-driven architectures on AWS. CloudWatch Events was originally built to respond to changes in your AWS environment. It provided a basic event bus and routing mechanism, but its scope was tightly bound to AWS service events and simple filtering. EventBridge expands dramatically on that model. One of the most impactful enhancements is the built-in schema registry and automatic schema discovery. This feature lets EventBridge capture the structure of your events in real time, catalog them, and even generate code bindings. This reduces the guesswork for developers and makes consuming events much easier and safer. Another major advancement is the introduction of custom event buses. These allow teams to define and manage their own event streams independently, improving logical separation, scalability, and governance across domains and microservices. Filtering has also been significantly enhanced. Where CloudWatch events offered basic pattern matching, EventBridge brings deep content-based filtering. With support for JSON path expressions and complex matching conditions, you can now route events based on any attribute inside the payload, offering much more precision and flexibility. EventBridge also improves multi-account and multi-region event routing. While CloudWatch events could support this with extra configuration, EventBridge enables it natively and securely, making it easier to implement organizational best practices across large AWS footprints. And finally, EventBridge introduces a more modern API, higher throughput, and a better developer experience overall. It's not just a rebranding, but a platform evolution designed to support the needs of today's distributed, event-driven systems. To fully harness the power of Amazon EventBridge, it's important to understand its core components, the building blocks that make event-driven architectures possible on AWS. At the center of it all is the event bus. This is the channel through which events flow. EventBridge provides a default event bus that captures events from AWS services, custom event buses for application-specific events, and a partner event bus designed for SaaS integrations. Each event in EventBridge is a structured JSON payload. It includes key metadata, like the source of the event, the detail type, a timestamp, and a detail section that carries custom data. This flexible structure makes EventBridge suitable for everything from infrastructure events to domain-driven design patterns. Rules are the logic layer of EventBridge. They act as filters, using pattern matching to determine which events should trigger which actions. A single event can match multiple rules, allowing for fan-out to multiple targets and enabling parallel processing of event flows. Matched events are delivered to targets. These can be a wide range of AWS services such as Lambda functions, step functions, SQS queues, SNS topics, Kinesis streams, and even external HTTP endpoints via API destinations. The schema registry is another powerful component. It automatically detects and catalogs the structure of your events. With schema discovery enabled, you can generate strongly typed code bindings in multiple languages. For compliance, analytics, and debugging, EventBridge offers event archiving. You can selectively archive events on any bus and retain them for future inspection. These archived events can be replayed using the Event Replay feature, enabling reprocessing of historical data without requiring the source systems to re-emit events. This illustration depicts the robust architecture of Amazon EventBridge, purpose-built to enable seamless, real-time, event-driven integration across your AWS environment, third-party SaaS providers, and custom applications. It begins with event sources, which can come from three primary origins. First, AWS services themselves can emit, such as EC2 state changes, S3 object uploads, or code pipeline deployments. Second, you can publish custom application events, allowing your own systems to signal important business milestones. Third, SaaS applications like Zendesk, Auth0, and Datadog can push events directly into EventBridge via partner integrations. Once an event enters the system, EventBridge organizes these events using event buses. The default event bus handles AWS service events automatically. Custom event buses are used for your own application-generated events, giving you full control over naming and organization. Meanwhile, SaaS event buses provide a dedicated channel for events from integrated third-party partners. After events land on the appropriate bus, rules are applied to determine how each event should be handled. Rules filter events based on specific patterns within the event structure, like service type, detail type, or payload content. This ensures that only events matching your criteria trigger downstream workflows. From here, EventBridge routes events to various targets. These targets span a wide array of AWS services: Lambda for lightweight compute, step functions for workflow orchestration, SNS and SQS for messaging, and Kinesis data streams for real-time analytics. Beyond AWS, events can also be delivered to API destinations, including Slack, PagerDuty, Zendesk, or custom webhooks, making it easy to tie into external systems and services. This architectural approach empowers you to build loosely coupled, scalable, event-driven applications. By decoupling the producers and consumers of data, EventBridge helps your systems react quickly and intelligently to changes across both cloud-native and SaaS platforms. A key strength of Amazon EventBridge lies in its powerful and flexible event filtering capabilities. At the heart of this functionality are event patterns, JSON-based structures that define the filtering logic applied by EventBridge rules. When an event is published to an EventBridge bus, each rule evaluates that event against its pattern. If the event matches the pattern, it is routed to the rule's configured target or targets. This enables highly targeted and efficient event routing without requiring any processing logic in the producer or consumer. Event patterns support content-based filtering, allowing you to match events based on specific fields like source, detail type, or deeply nested keys within the detail payload. You don't need to define the full structure of the event. Partial matching is supported. If the specified fields in your pattern are present and match, the rest of the event is ignored for matching purposes. This makes it easier to write concise and resilient patterns. EventBridge also supports multi-value matching, enabling OR conditions within a single rule. For instance, a pattern can match events from either US East 1 or US West 2. Advanced features like the Anything But operator allow you to exclude specific values, while the Exists operator matches based on whether a field is present. You can even use the prefix operator for string pattern matching, which is especially useful in event naming strategies that use hierarchical naming like invoice.created or invoice.failed. You can also filter on complex nested fields, enabling sophisticated routing logic based on deep business context, like routing only refund events from users in a specific region with a loyalty tier above a certain threshold. All of this filtering happens at the bus level, which means only relevant events are forwarded to targets. This reduces downstream noise, improves performance, and allows your event consumers to remain simple and focused on their business logic. One of the most developer-friendly features in Amazon EventBridge is its schema registry and discovery capability. In modern event-driven systems, managing the structure or schema of your events is critical for maintainability, documentation, and interoperability. EventBridge addresses this need by providing a built-in schema registry. The schema registry acts as a centralized repository for all your event structures. Whether events originate from AWS services, custom applications, or SaaS partners, their schemas can be cataloged and browsed in one place. This provides clarity to teams across your organization, helping everyone understand what data is being emitted and consumed. With schema discovery enabled, EventBridge can automatically inspect and extract the structure of incoming events in real time. This means that as your applications emit new types of events, EventBridge will detect and register them for you, removing the manual overhead of managing event formats. EventBridge also handles schema versioning. Each time an event structure changes, a new version is recorded in the registry. This makes it easy to track how your event models evolve over time and allows consumers to choose the version they depend on, improving compatibility and safety. One of the most practical features for developers is the ability to generate code bindings directly from the schema. Whether you're writing in Java, Python, or TypeScript, you can download SDKs with strongly typed models of your event data. This not only accelerates development, but also reduces bugs by eliminating guesswork in how event payloads are structured. Schemas are expressed using industry-standard formats like JSON schema and OpenAPI, which means they're compatible with existing tooling and validation libraries. This makes it easy to integrate EventBridge into CI/CD pipelines, contract testing frameworks, and documentation tools. You can also search for and tag schemas in the registry, making it easier to organize and reuse standard event formats across teams or domains. For example, a finance team could tag all their invoice-related events, while a product team might tag events related to usage analytics. Amazon EventBridge Pipes introduces a new, streamlined way to connect event producers and consumers with minimal effort and no custom glue code. Pipes simplify the process of building point-to-point event-driven integrations by abstracting away the heavy lifting typically involved in filtering, transforming, and routing events. At its core, an EventBridge pipe creates a direct, managed connection between a supported event source, like an SQS queue or DynamoDB stream, and a target service, such as AWS Lambda or step functions. This eliminates the need to manually pull sources or write boilerplate logic to forward data. One of the powerful features built into pipes is event filtering at the source. This means you can define filter criteria to ensure that only the events relevant to your use case make it through the pipeline and reducing noise. Equally important is the ability to transform and enrich events in flight. Pipes support transformations using either a lightweight built-in input transformer or an AWS Lambda function. This lets you reshape the payload to match the target's required format, mask sensitive data, add contextual metadata, or flatten nested fields. The entire setup is designed to be low-code and developer-friendly. You can configure everything from the source to the transformation logic and target through the AWS Management Console, CloudFormation, or APIs, enabling rapid iteration and deployment of event flows. Resilience is built in. Pipes support integrated retry policies and dead letter queues, helping to ensure that transient issues like network timeouts or throttled targets don't cause data loss. Persistent failures are safely redirected to DL queues for later inspection or reprocessing. By using EventBridge pipes, teams can dramatically reduce boilerplate integration code. There's no need to write polling daemons or maintain intermediary infrastructure. And because EventBridge pipes are fully managed, they scale automatically with your event volume, providing high availability and fault tolerance out of the box. This illustration demonstrates how Amazon EventBridge Pipes simplifies event-driven integration across a wide range of AWS services. At its core, EventBridge Pipes offers a managed, low-code solution to build event processing pipelines with filtering, transformation, and enrichment, without writing or managing custom code or infrastructure. The process begins by ingesting events from supported sources. These can include common AWS services like Amazon SQS, Amazon Kinesis Data Streams, Amazon DynamoDB Streams, Amazon MSK, and Amazon MQ. These services often emit high-volume, high-frequency event streams, ideal for real-time processing. EventBridge Pipes acts as the connector that draws these events into a streamlined pipeline. Once the events are inside the pipe, users can apply filtering rules directly within the pipe configuration. This ensures that only the relevant, meaningful events continue through the workflow, minimizing unnecessary downstream processing and cost. Next comes enrichment and transformation. EventBridge Pipes supports the ability to modify or restructure events. You can enrich them by invoking a Lambda function or transform their schema using built-in capabilities, allowing you to shape the data exactly as your targets expect it. After the transformation stage, processed events are routed to various AWS services. These include AWS Lambda for serverless execution, step functions for managing workflows, or Amazon API Gateway for triggering APIs. Additionally, EventBridge Pipes supports delivery to API destinations, enabling secure outbound HTTP requests to SaaS applications or custom APIs. Ultimately, the events can be sent to AWS targets, including EventBridge itself, enabling even more downstream routing and fan-out patterns. With Pipes, AWS gives you a highly configurable, scalable, and cost-effective way to build robust event-driven workflows without building and managing plumbing logic from scratch. Security and compliance are foundational pillars of any enterprise-grade architecture, and Amazon EventBridge is designed with these principles at its core. It provides a robust set of features to help organizations securely build and govern event-driven applications at scale. At the forefront is IAM-based access control. Using AWS Identity and Access Management, you can define fine-grained policies that govern who can create event rules, publish events, manage event buses, or interact with the schema registry. For cross-account scenarios, EventBridge supports resource policies that can be attached directly to event buses. In terms of data protection, all events are encrypted in transit and at rest. TLS is used to secure data as it flows between components, and events stored by EventBridge are encrypted using AWS managed keys by default. This helps ensure confidentiality and integrity of data throughout its lifecycle. For organizations with strict security policies, EventBridge supports customer-managed keys through KMS. This allows you to manage your own encryption keys, set key rotation policies, and enforce granular access control over those keys. For external API destinations, EventBridge supports AWS Private Link integration, which allows you to route traffic securely through the AWS network rather than the public internet. This significantly reduces the attack surface and ensures private connectivity for outbound event flows. Another crucial feature for governance is integration with AWS CloudTrail. Every API call related to EventBridge, including creating or updating rules, modifying event buses, and accessing schemas, is logged in CloudTrail. This provides a detailed audit trail for forensic analysis, compliance reporting, and operational transparency. EventBridge is also built to comply with key industry standards. As part of the broader AWS ecosystem, it benefits from the platform's certifications and compliance programs, such as SOC 1, 2, and 3, ISO 27001, HIPAA, and GDPR. Amazon EventBridge follows a transparent pay-per-use pricing model that aligns with serverless principles. So you only pay for what you actually use. There are no upfront costs, no infrastructure to manage, and no idle capacity charges. This makes EventBridge an attractive choice for workloads that are dynamic or variable in nature. It's important to understand that these operations are priced independently. For instance, if you publish 1 million events to an event bus, and those events match 2 different rules, and each rule delivers to one target, you'll be charged separately for publishing, 2 rule matches, and 2 deliveries. If your use case involves sending events to external systems, EventBridge offers API destinations, but these come with their own pricing. Each invocation of an external API via EventBridge incurs an additional cost. For advanced event workflows, EventBridge also supports EventBridge pipes, which are priced based on the number of events flowing through the pipe. If you apply transformations using AWS Lambda or input transformers, there may be additional charges depending on the processing performed. If you're leveraging the schema registry, basic discovery and storage are included at no extra charge up to certain limits. Beyond that, pricing is based on the number of discovered schemas and the number of code bindings downloaded for use in development environments. To get started, AWS provides a free tier of 100,000 events per month. This is especially useful for developers and small teams running test environments or low-volume production workloads. Another aspect to consider is cross-account or cross-region event delivery. While sending events within the same region is covered under standard pricing, routing events to other AWS accounts or across regions may introduce additional data transfer costs and should be planned accordingly. Monitoring and observability are critical components of any event-driven architecture, and Amazon EventBridge provides multiple integrated tools to ensure visibility, traceability, and resilience across your event flows. To begin with, EventBridge automatically publishes key operational metrics to Amazon CloudWatch. These metrics include the number of events published, how many matched rules, delivery success or failure counts, and throttled events. This allows teams to track system health and performance in near real time. You can go a step further by configuring CloudWatch alarms based on these metrics. For example, you might set up an alarm to trigger if event delivery failures exceed a certain threshold, or if there's an unexpected drop in event throughput. These alarms enable proactive detection of anomalies and help minimize downtime or data loss. For deeper operational insight, EventBridge offers event archiving and replay. You can configure your event bus to retain events for a defined period, from hours to days or longer, and replay them to the same or different event buses. This feature is invaluable for debugging issues, backfilling missed data, or rerunning processing logic after downstream updates. When it comes to reliability, dead letter queues, DLQs, play an important role. For supported targets like Lambda, failed event deliveries are captured in DLQs. This ensures that problematic events aren't lost and can be reviewed, diagnosed, and reprocessed at a later time. While EventBridge itself doesn't natively support AWS X-Ray, you can instrument downstream targets like Lambda functions or step functions with X-Ray. This provides end-to-end tracing of event flows, allowing developers to see latency bottlenecks, errors, and service interactions in distributed systems. Finally, AWS CloudTrail logs all API calls made to EventBridge, including rule creation, deletions, schema changes, and permission updates. These logs are essential for auditing and maintaining compliance across environments where governance and traceability are key. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.